Welcome to VGuide TV. In this video, I am giving a very shortcut. It's a very important trick to solve the question of electrostatics. A typical question of electrostatics. See the question. Two long wires are placed on a smooth horizontal table. The wires have equal but opposite charges. The magnitude of linear charge density of the wire is lambda. Calculate the work required to increase the separation between the wires from A to 2A. See here, they are given two wires, one of positive charge, other one of negative charge. But their linear charge density they are given as lambda. I need to find, now they are separated, right? Now we need to move it from A to 2A. What is the work required for the purpose? So by seeing the wire itself, you can understand that they are unlike charges. So definitely they shows an attraction. So if we need to move from A to 2A means definitely we should do some work. Okay. So work we need to do. Work is nothing but force into displacement. So your general equation for work is force into displacement. So here what I am doing is, first I am finding, you just take this as a wire with a positive charges. So I need to find what is the electric field due to this wire at this point. So I need to apply the Gauss law and all. So I'm just showing here what are the main equations you should remember. Flux is E dot S. Electric flux is E dot S or E dot A. Okay. E is electric field, A is area. Flux can also be written as Q by epsilon naught. Lambda. Lambda is linear charge density, Q by L. So what I'm doing here is, with respect to this wire, I'm just assuming that I'm assuming a cylindrical region like this, right? So I'm going to find this wire is at a distance x from the first wire. So I'm going to find what is the electric field at this region first, because my second wire is placed in the electric field produced due to first wire. So I need to find what is the electric field here. So for that, first I've calculated the flux. Flux is Q by epsilon naught. Q, this is a linear charge density, so Q is lambda L by epsilon naught. And in the question they told, for the unit length you calculate. So I'm putting L as 1 or L as 1. So we get flux equals lambda by epsilon naught. Your equation number 1. If you want force, force equals QE. Same thing we are doing here. What is the force I'm calculating? Force is Q into E. Q I need to write in terms of lambda. So lambda L into E, whereas L we are taken as, what is the length we are taken? 1. So lambda L into E. What is E from here? E means I have written an equation lambda by 2 pi epsilon 0 into R, because you know the standard formula, right? We know the standard formula of electric field due to a wire. Okay, what is electric field due to a wire? E is equal to lambda by 2 pi epsilon 0 into R. So in this case, the distance is x. So I can write lambda by 2 pi epsilon 0 x. So we get the second equation, that is lambda into lambda square by 2 pi x epsilon naught. Okay. So I got what is the force. But the question is to find work. Work is nothing but integral of f dx. That is integral of, from where to where we need to move, A to 2A, A to 2A. Force is lambda square by 2 pi x epsilon naught into dx. Constant term, take it out. Lambda square by 2 pi epsilon 0 into integral of dx by x. We need to move from A to 2A. What is integral of dx by x? Log x. So we can write here as lambda square by 2 pi epsilon 0 log x. From where to where? A to 2A. Upper limit minus lower limit. That is 2 see here, upper limit minus lower limit. That is log 2A minus log A. It can also be written as log A minus log B. We can write it as log A by B. So we can write here log of 2A by A get cancelled. So we get an answer log 2. Very important question. Lambda square by 2 pi epsilon 0 log 2. So remember how we are doing. They gave two wires. They are placed at a separation. So first I'm calculating one wire I'm taking into consideration. Due to that wire, what is the electric field produced here we are calculating. I used by Gauss law first application direct lambda by 2 pi epsilon 0 r, right? Then after that, this is the electric field, means what is the force QE. Okay, the first one and all I have written here like a for flux only, not required. Okay, so from here directly you can write, no problem. From here you can write F equal QE, Q equal lambda into E. Lambda we can write it as lambda into 1 into F equal QE, Q we can write lambda L into E, L equal to 1. So lambda into E, lambda by 2 pi epsilon 0 into X, we get the force. Work done, integrate it. When we are integrating here, remember integral of dx by x is log x within the limit from 0 to 2a. Upper limit minus lower limit, that is 2a minus log 2a minus log a. That again we can write it as log a by b. In that way I get an equation lambda square by 2 pi epsilon 0 log 2. Clear? I hope you got this video. You understood the concept. So see, it's little higher version of your Gauss law. Thank you. Subscribe our channel, V Guide TV.